Ladies and gentlemen, welcome to the first event of the Sustainable Powertrain Tour 2022. We focus on zero-emission commercial vehicles. Okay, and if e-axle was the leading solution for powertrain efficiency, a tricky question, frankly speaking, whose answer is far from predictable. To find out more about it, we asked Sustainable Truck and Van for help. So you can see on my right side, my colleague Fabrizio Dalle Nogare. Thank you for being here. Thank you for helping us.
Thank you, Fabio. Thank you very much. A warm welcome greeting also from my side. As some of you may know, Sustainable Truck and Van is a young web platform. We celebrated the first year a few days ago, focused only on zero-emission commercial vehicles. We truly believe there is so much to say about the new trends in the truck and van sector. Today, we're wondering whether the electrification of axles may be an in-between step in the energy transition, which is also useful in the repowering scenario. Or is it an ultimate and necessary solution? We are extremely proud of the panel that will help us go into details. So, thanks in advance in order of appearance to Stuart Bradley, Head of P&D Power Electronics, Motors and Drives and Propulsion Systems at Ricardo's Automotive and Industrial Business Unit. Thank you to Robert Carter, Chief Engineer Powertrain and Thermal Systems at Volta Trucks. Michael Foster, Executive Director and CTO, and also Ashley Brooks, Area Director UK and ROE, and EMEA Segment Manager, Allison Transmission. Danilo Bonera, Chief Technology Officer at Brist. John Bennett, Vice President and Chief Technology Officer at Meritor. Andreas Grossel, Vice President, Global Product Segment Leader, E-Mobility Driveline at ZF. And also Massimo Galli, CEO and founder of EV.
Such a great panel indeed. So before we start, let's say that the webinar is going to last around roughly an hour and a half, and that will be available on both Powertrain and Sustainable Truck and Van YouTube accounts and websites. So, to engage in the logic of electrification without falling into the trap of catchphrases, we have to start with an overview and then break down the puzzle piece by piece. Mr. Stuart Bradley from Ricardo will start from this topic, providing an overview on the current trends as for powertrain layout of commercial vehicles. Please.
And thank you very much for having me on this webinar as well for Sustainable Truck and Van. It's a real pleasure. Thank you. I'd like to share my screen and go through my presentation. So what I'd like to talk about today is the world of light commercial vehicles drivetrain development and some of the trends that we see happening. Now, vehicle ownership and use is changing, and so are users' expectations. And if we look at these in a pest analysis, looking at particularly at political factors, economic factors, we can see that for society, there's a big change towards the strict management of urban air quality, as well as the reduction in CO2 emissions. What we also see are that economics will play a bigger part in things. So things like the initial cost for a new business model, and also for the requirement for increased vehicle uptime. And those sorts of drivers will change the vehicle ownership and also the type of users experience. And then when we look at things like the social factors, then we would expect to see that reduced vehicle outright ownership models will change, and maybe we'll start to see more emphasis on mobility as a flexible and profitable service. And then also in terms of there being some really difficult challenges in terms of the infrastructure that needs to be developed and the amount of uncertainty that we see with that sort of infrastructure. And a typical example of that might be range anxiety. It might be wondering how to charge up your vehicle, either at a building site or on the move, and maybe we'll see some changes in terms of opportunity charging there as well. In terms of driveline architecture challenges, then if we look at the vehicle requirements, then the total cost of ownership is certainly one of the biggest challenges. And then looking into that cost of ownership, we can see that, of course, low energy consumption is a primary concern, as we're seeing great uncertainty in terms of energy costs. And through the transition from a fossil fuel economy to a low carbon economy, we'll see more emphasis on energy consumption and energy preservation as well. And part of that we'll see low initial purchase cost being one of the primary enablers. And looking at the driveline, then of course the e-machine and power electronic selection in terms of its purchase cost is quite critical. It also affects the efficiency and energy consumption, and then the complete system together with the transmission architecture as a whole system becomes more important and of concern. So can electric drivelines meet these challenges? The challenges are reduced bill of materials cost, improve efficiency, of course, increase the power density, and to, of course, increase robustness, including reliability. Now, those challenges can be met with, in particular, a whole system analysis and mindset in terms of the design drivers. So deeper integration of mechanical, thermal and electrical systems. In terms of supply chain impacts as well, we would expect to see reduced emphasis on rare earth materials. At the moment, permanent magnets are de rigueur and are certainly used in most high efficiency, high power density motors. We would also expect to see more use of wide bandgap materials in the power electronics, so SiC and GaN especially, and also the move to high voltage architecture, 800 volts and above, as we're seeing today in some high performance cars like Porsche and Hyundai and so on. In terms of integration, then one of the key enabling technologies is going to be the development of more advanced cooling systems, more efficient cooling systems, and together with the application of multi-speed transmission, gives some of those advantages in terms of power density and efficiency. At Ricardo, we've been looking at the increasing integration of power electronics, motor and transmission as a way of improving those attributes, and of course the cost situation as well. So we've worked on multi-speed electric drives, integrating the inverter into the drive, and a greater integration of the thermal control system into both the motor, inverter and transmission. So these are primarily EDU units. In the lower part of the slide, you can see some of the significant projects that we've worked on in terms of enabling those 800 volt systems. So we've developed a 250 kilowatt silicon carbide inverter. There's a picture there in the middle of that. It's a fairly compact unit, very efficient, and the bill of materials cost is quite moderate. For some of the future technologies, we have started working on GaN inverters as well. Now, we expect that the future cost of GaN will drop rapidly as more and more consumer electronics use these wide bandgap materials. On the motor side, we've been working on an aluminium motor, we call Alimotor, no rare earth materials, and aluminium windings removing copper. So that is a significantly lower cost and higher robustness motor. For the 2022 projects, we're looking at greater integration of the inverter with motor, but also looking at integrating power electronics with batteries in terms of our multi-back project, and then also inverter and onboard charger and DC to DC converter integration. So having a single power electronics package will help with both cost and packaging. I'd like to briefly go through a couple of projects and tell a little bit about the way that we see the route to greater efficiency and lower cost. So certainly, looking at the whole system, motor, inverter, transmission, along with the vehicle itself, gives some insights into the number of gears that we need, for example, the number of gear sets, the type of motor, in terms of its speed range and knee point, where the constant torque and constant power take over, especially applied to delivery vans and light commercial vehicles. And what we see is the total system cost can be reduced, that the bill of material cost for a fairly high power and high acceleration driveline can be reduced from, or let's say, £12,000, sorry, 13,400 down to about £12,000. In terms of the two-speed EDU, we see integration of the electrical machine and inverter in this particular project. The first gear reduction is an overall ratio of around about 13:1, and the second gear around about 5.5:1. Now, those have been chosen specifically to improve efficiency, so to be able to keep the motor and inverter in the most optimal point for efficiency, but also to reduce the overall bill of materials, in particular the gear train. Looking at a further project, the diode project was sponsored by Innovate UK. We specifically wanted to look at disruptive cooling methods. So taking thermal management from other types of industry, applying them to integrated inverter, motor, and transmission. And what we wanted to do was to compare against the baseline machine, which was an oil-cooled machine, a water-cooled SiC inverter, and take advantage of some of the whole system attributes. So being able to take cold oil from the transmission sump and cooler into the inverter, then into the machine, and delivering warm oil to the transmission at exactly the right temperature. This level of integration meant that we were able to reduce the mass and volume, but especially the cost as well. In terms of cost reduction and improved robustness, the Alumotor machine uses a permanent magnet-free synchronous reluctance motor concept. It has aluminium windings, and together with our project partners, we're looking at establishing a volume manufacture pathway for the composite rotor, for additive manufactured components, and especially looking at improved bill of material cost. And we're aiming to beat the Advanced Propulsion Center cost target of $3.60 per kilowatt installed by 2035, which is a fairly aggressive target. And combine that also with the performance target of around about 120 kilowatts, operating on an 800-volt architecture, of course. And that prototype machine is due for demonstration in summer next year. We'll also have a high-performance version as well, which will be working at somewhat higher speed, again 800-volt architecture, and with a fairly moderate power density of up to 4 kilowatts per kilogram. But the emphasis on this machine really is in terms of low cost and high robustness. Now, in terms of robustness, we think that this attribute is going to be particularly attractive for working vehicles, where the operator needs to be able to have the machine on the road and earning cash as much as possible. So robustness would also include reliability, availability, and a certain amount of end of life and the circular economy attributes as well. In particular, being able to know when and what route is best to take at the end of life. So do we rewind, do we remanufacture, recover the materials. Just to sum up now, then we see the trends as being particularly focused on efficiency and total operating cost, but without significantly affecting robustness, reliability, availability. To be able to do that, we believe that sustainability and supply chain improvements are critical, and that cost reduction pathways have been identified, and we believe that they can be met. In terms of EDUs, we see advantage over other drivelines, again in terms of capital cost reduction, but especially in terms of packaging, which is so important for light commercial vehicles. And of course, underlying all of this is efficiency improvements that give those total operating cost targets. Thank you.
Mr. Bradley, thank you very much. Now, as deductive logic tells us, let's go deep in a very concrete case study. Volta Trucks is an aggressive startup in truck electrification. Their goal is to make city centers cleaner with their Volta Zero truck. Robert Carter, how is the Volta Zero made, and what are the reasons behind the choices you made for its powertrain? Please.
Hello, everyone. So thank you for the warm welcome, and I'm here to bring you Volta Trucks' perspective, to bring an OEM's point of view as to why you might select the e-axle for a commercial vehicle. So I'll start the story by giving a small amount of background to Volta Trucks and our vehicle. Just waiting for my slides to catch up. Okay, so I'm sure many of you are familiar with Volta, but just so that we're clear, Volta Trucks was founded in about 2019, and our mission is to be the leader in zero-emission transport, making cities safer. We're doing that through our vision of delivering all-electric commercial trucks into city centers and revolutionizing the vehicle ownership. You might have heard some of my colleagues talk about TaaS, truck as a service. That's our mechanism by which we are hoping to support and accelerate the uptake of EVs and bring sustainable commercial vehicle operations into cities. Our purpose, as it says, really is electric trucks for sustainable cities, with people at the heart of everything we do, both here internally at Volta and in the cities and partners that we work with. You asked about the e-axle for the Volta Zero. The Volta Zero is our first vehicle. It's a 16-ton product. And I'll just tell you a little bit about that because it sets the scene of why an e-axle. We see this as the first wholly reimagined truck in this segment. And I say that because it really is purpose-built for the environment and use case that it is intended for. Urban distribution, a city center environment. And you can see that starting from the front of the vehicle. I look at that low floor cab, easy ingress and egress for the driver, both sides of the vehicle. There's the low driver's seating position. It puts the driver's eye line at the same height as that of particularly vulnerable road users, cyclists, pedestrians. There's 220-degree all-round vision from that glass cab at the front. And for us, that's really a part of the outstanding driver experience. It's a good vehicle to be in and to use, but also the safety and connecting the driver to vulnerable road users through the kind of opportunities that front-end design brings us. The choice of the EV powertrain, whichever form, really speaks a lot to the sustainability credentials alongside our choice of materials on certain areas of the vehicle. As I say, it's a pure EV truck. It has a 200-kilometer range. And it's available with ambient or refrigerated cargo bolters. But the point, why use an e-axle for the Volta Zero? What were our key criteria? I will start with the Volta Trucks concept. So the kind of topics that I've just mentioned, we really did start with delivering a purpose-built truck that was suitable for the urban application. And that meant that glass cab, the low driver seating position came first. The visibility, safety, the driver environment came first. There were no preconceptions for us around a powertrain layout that we must use or should use. There was no pre-existing powertrain or internal combustion engine that we had to site in a particular location. And naturally, that already makes you think about an e-axle as an opportunity if you've got that blank sheet of paper. But there are a few key reasons that I'll dive into that really made us make that choice for e-axle. I'll start with packaging and integration. The e-axle unlocks many packaging options, and it particularly unlocks some key packaging options for us with the Volta Zero. That low floor cab at the front comes with the knock-on effect that you don't have access to the space under the cab that you'd conventionally use for powertrain, whether it's the engine in an ICE truck or whether it's the EDU in a more conventional powertrain layout. That space is gone. And so you're looking at the space behind the driver's cab, typically up to the rear axle in which to package your powertrain. And you've still got to leave space for tail lifts, other equipment that's important on a commercial vehicle. And so the e-axle enables that. And additionally, it frees up all of the spine space in the vehicle because you don't have a drive motor that might be centrally mounted and a prop shaft that's running down the length of the vehicle. For us, that really helped put safety first as well. We had a key ambition to get the high voltage batteries between the chassis rails on the vehicle, protect them from side impact, and the e-axle really unlocked that scenario for us, and that was a strong driver. I guess having said those things, we didn't set out to reinvent the wheel. An e-axle is, with a conventional commercial vehicle axle, part of its setup is compatible with conventional commercial vehicle chassis and suspension components and design. And we have a conventional ladder chassis on the vehicle. And so for us, that was part of delivering a robust vehicle to our customers. It enabled us to pick the right technologies for the chassis and the suspension. There are other technical nuances of this. I mean, I mentioned reduced loads on the chassis. You have the advantage that you lose the torque reaction that typically takes place with the chassis being a part of that load path with a kind of front-mounted engine or drive unit driving down a prop shaft, the rear axle. All of that torque loop is now self-contained within the e-axle casing and housing. Customer priorities, payload for a commercial vehicle is key. I guess it's part of the total ownership piece, total cost of ownership that we've heard about already. And the e-axle really helps pure EVs remain payload competitive because you're optimizing the configuration of motor casing, transmissions casing into a small unit at the rear of the vehicle, you're dropping the prop shaft, etc. Driving performance, I mean, arguably this applies to any EV driveline that we might have picked, but we certainly weren't going to compromise in this area with our selection of an e-axle. It was really important for us that whatever we picked could match or improve on comparable ICE vehicle or other EV powertrain layout options. I mean, the drivability side is key for us for a city center vehicle with lots of stop-start usage. Yes, it's not a performance vehicle, but we expect the acceleration, gradability, etc., to be comparable. We want drivers to be able to get in this vehicle and understand how to drive them, not feel that difference or kind of lack of performance. Lifetime performance is key. We needed a solution that was commercial vehicle ready. I've talked about having an opportunity to have existing commercial vehicle technology integrated. We looked at options like hub motors, individual wheel motors. That didn't really fulfill that criteria for us, whereas an e-axle based on an existing commercial vehicle axle platform really does. And again, you're reducing exposed moving components. All of that is part and parcel of the improved maintenance. Supplier capability was a key criteria for us. Yes, if we were going to do something arguably slightly different at the time we made the decision and go with the e-axle, we couldn't compromise in this area. The e-axle was a key part of the Volta Zero. We needed to find a product and a supplier that had the technical maturity in the product, but also the production capacity and experience in the commercial vehicle sector to support us in bringing the Volta Zero to market and supporting our volumes. So the organizers asked me as well a bit about the development process of an e-axle into the Volta Zero. I'm sure many of you will be aware, if you've been following Volta, that we're using the Meritor 14xe e-powertrain platform. I certainly can't claim to have been involved in the design of that, and I'm sure John will tell us a bit more about that later on. But the involvement or the relationship, if you like, between Meritor and Volta was very much around the integration of that axle into our vehicle. So that started out from all of the typical areas you'd expect: the suspension integration, appropriately customizing, developing the brake configuration, hub configuration for the markets that we were going into. That involved integration on the high voltage systems, compatibility with the rest of the vehicle, obviously the control systems as well. And I mentioned that the e-axle unlocks the packaging scenario for us. It certainly doesn't make it easy. There was a lot of work on packaging the e-axle, getting the batteries into the spine of the vehicle, and packaging everything around that. From then, we went forward into our first rolling chassis prototype, if you like, which is the vehicle you see next along that timeline. That for us was really the opportunity to prove that an e-axle works in a commercial vehicle, prove that it works with the chassis design we've selected, the battery pack, that we could have the performance, that we would have the payload, capacity, weight distribution across the vehicle with that setup. And it really did demonstrate that to us and gave us the confidence to keep going with the e-axle, moving straight on into what was our design validation vehicles. You see one of them there was in Sweden earlier in the year doing cold environment testing as part of a suite of tests that we've done on the vehicle to demonstrate that the e-axle really have been the right choice for us and can deliver the vehicle performance that we require. That grayed out image for me kind of represents the future. I can't yet manage photos from the future, but that's a truck on a street. That's the rest of the journey for us, which is on into production validation and start of production. I'm really looking forward to continuing the e-axle journey. When I reflect on where we've come since the concept stage, it's obvious that the e-axle was the right choice for us. It really has unlocked the kind of concept of the Volta Zero as we intended and as you kind of see it today. So I'll leave you with a very short video from one of our recent short video series. Courtesy, credit to Meritor for some of the footage in this.
Fine, we finally understood what it means to develop and apply an electric axle on an EV truck. Okay, Mr. Carter, if you agree, I'm going to call for specialists of the e-driveline. I could call it mission transmission or mission emission, nothing would change. There are Allison, Brist, Meriton, and ZDEV. I thank you in advance because you will enable us to get a holistic view of this issue. Starting from the A, Allison is the first, isn't it, Fabrizio?
Of course it is. We've got two speakers now, Michael Foster and Ashley Brooks. Up to you is going to start. What about the evolution from traditional automatic transmission to electrification? Please.
Yeah, thank you for the question and great presentation there by Volta Trucks. I think it explains a lot about the benefits of the e-axle. There's a lot of challenges going from automatic transmissions where we've integrated for years with diesel and other internal combustion engines going into that e-axle space. One of the things I think that was touched upon in prior, in the prior message was really that reliability and total cost. So, one of the challenges, while we haven't traditionally been an axle manufacturer, was really leveraging those core capabilities that we have in terms of understanding the torque and power management within the vehicle, whether that's from our experience in our hybrid applications that we've had in transit, where we manage the entire energy system on board the vehicle. Also integrating with diesel engines, understanding that more deeper integration, but bringing that forward then into that e-axle from a system level is very critical. I think leveraging that out of our core is going to position us well as we move into the e-axles. The other challenge then is to make sure that the products are robust, so leveraging what we've done in the automatic transmissions from the perspective of durability and reliability is also going to be key. I think as we are all spending a lot of R&D dollars on this transformation to electrification, I think it's only beneficial for the entire industry to be successful as we go into that. And Allison is really trying to leverage those core competencies that we have from a durability and reliability perspective to make sure that our e-axles can live up to that same Allison brand promise. Now, some of the challenges are, we're moving from a traditional sprung mass location to now between the wheels where there's a lot harsher environment. So there's some challenges associated with that to make sure that the shock and vibe profiles, can also be sustained in a durable product. So that's been a little bit of a learning curve for Allison, having not been in that position, say, similar to what Meritor has been. But I think, the challenge is just going to be able to get a family of products out there to meet the demands of the very wide array of applications in the commercial vehicle space. We're all familiar with, the light-in pickup and delivery all the way up to Class 8 vehicles. So there's a huge variety of duty cycles, applications, gradability, top speed. How do you develop and design and validate a full axle family, e-axle family, in the space to cover that? Today, Allison Transmission, we've got a number of products in our on-highway portfolio to cover that, and we have a lot of proliferation in the models and in the feature sets and gear ratios. So really trying to package all of that into the e-axle and into a portfolio, does present challenges. I think we're all faced with that as suppliers to this space. But quite frankly, I think the benefit for all of us on this panel is we are leveraging, a core that has been developed over many years, decades, and for some of us a century. So leveraging that is going to make us successful, but recognizing that it's new sets of requirements certainly presents challenges.
Thank you very much, Mr. Foster, for your point of view, of course. Danilo Bonera is the CTO of Brist. We know the company's core business is on independent suspensions. Could you please tell us more about it? And how do these interact with the choice between e-axles or traditional axles? In other words, why are independent suspensions crucial for commercial vehicles in the future from your point of view? Please, Danilo.
Yeah, thank you. So our company was generated under Voith umbrella, as you may know, and it was generated specifically to design independent suspension. So in our history, we designed and produced many independent suspension, starting with traditional vehicles, so combustion engine vehicle nearly 20 years ago, to electric vehicle in the last years. And today we reached the widest range of independent suspension for commercial vehicle, as we go from 2 ton to 12 ton. That means we go from 16-inch axle independent to 17.5 axle, 19.5, and 22.5 inches independent axle. And we are the only company, at least in Europe and America, having so wide range of independent axle. But we don't supply only independent axle. We do also more traditional axle, but especially for independent and electric, we also combine this solution with our single and multi-speed reduction. So multi-speed is a new program we launched a couple of years ago, and now is going to be finalized and shortly presented to the market. So in the electric vehicle, designed from scratch. So as you surely know, so the game changer is the cancellation of the combustion engine driveline. So the introduction of the electric motor in place of the combustion engine motor and the introduction of the battery is totally changing the weight distribution, and is totally changing the space available on the vehicle. In addition, new electric vehicle, we always see that are preferred to be modular and flexible, to adapt maybe same platform to different bodies, different mission. For instance, we also quite frequently do platform that are then serving delivery van, and also minibus. So for these two reasons, the space and weight change, and also the high importance of the modularity, the conventional axle are not anymore the best fitting for electric vehicle. So our vision is quite simple. What we think is that for new generation of vehicles, so for electric vehicle, there is a need of new generation of axle. And what we do is we use our expertise on independent axle to create some electric solution. Why we do this? Because with independent axle, the modularity is extremely high. For instance, the vehicle width can be set to different values using the same axle. The driver position can be in any place, left, right, middle. The rear axle can be also steerable, and we have several applications with rear steering. There is a optional 4x2 drive or 4x4 using the same axle front and rear can be proposed to the market. And also very important, with independent axle in all position of the vehicle, also bidirectional driving is possible, and we already have some application in the market, and it's clear also from more confidential program that the new delivery vehicle truck are going to be autonomous and bidirectional. So regarding this point, we see that bidirectional is very important, and this is giving us even more confidence that independent axle is a key product for the future of the electric vehicle. In addition, independent axle is also allowing a space and weight saving. Space because it's very compact, and weight because compared to more traditional rigid axle, electric, for sure, good, futuristic, but independent is allowing to save 10-20% weight saving. And this saving in electric vehicle, you surely know, is allowing a range extension of the vehicle, or it's allowing to cancel some battery. So it's a big advantage in terms of range or in terms of cost cutting. So lastly, with the independent axle, is also easy to realize low floor ergonomic layout for in-city delivery. So as Brice, we started doing independent axle for buses, where ergonomy, low floor, and all these features are extremely important. And now we are carrying everything to the truck, especially to the delivery vehicle. And this is really very much appreciated, and this market of door-to-door delivery is booming, and we see that there is a need of such new solutions. So independent axle for us is a past, because it was the first product we generated under a Void Group, but it's also for sure our future. Thank you.
Okay, Mr. Bonera, as we just heard from Volta Trucks, Meritor is a partner for electrified assets. So tell us about this project from your specific point of view.
And thank you for inviting me here. It's my pleasure to be here today. First, it's been really great working with a company that's aiming to change transport, as Volta is. And in this regard, our visions are well aligned, because it's Meritor's vision to enable the industry to move towards clean transportation. That means offering e-axles that are affordable, provide similar or better performance compared to diesel trucks, are lightweight in order to minimize the impact of payload, and enable long range by being efficient and by opening up space to package more batteries, as Rob mentioned. Now, in order to achieve that vision, working with Volta has allowed us to demonstrate, 3 of our design principles that we've been focused on for e-axles, and that's maximizing configurability, maximizing integration, and maximizing reusability. So let me explain those. The first is maximizing configurability, because as everybody knows, commercial vehicles are extremely diverse, and a single e-axle platform simply won't work well in a broad range of applications when you look at durability, weight, and cost. To put this in perspective, we currently sell over 11 different conventional drive axle platforms in the medium and heavy duty segments today. each optimized for a specific segment of the market. Add to that the number of engines and transmissions used, and you can see just how complex a potential lineup of e-axles can get in a hurry. And all of them will be low volume, at least initially. So we're focused on building each e-axle platform with several motor options, several transmission options, a wide range of gear ratios, and several wheel end options that can all be easily changed and mixed and matched. This allows us to better optimize the performance, the efficiency, the cost, and the weight of the e-axle to the specific needs of each application without having to develop 11 e-axle platforms, at least at first. The second design principle we're focusing on heavily is maximizing integration, because we believe a highly integrated product will ultimately perform better, package better, save weight, and save cost. We're focused on the physical integration of the motor and the axle gearing, literally wrapping the rotor and stator around our pinion stem and bearings, but also the integration of the inverter and the motor on the axle. We're very mindful of the amount of mass that we're adding to the unsprung mass of the vehicle. So this type of integration helps reduce weight and also helps manage the overhung mass on the axle housing, which is very important from a reliability standpoint. We're also focused on software integration. And this has been really good working with Volta, who's also very focused on software integration and making sure that our systems communicate. We're looking at integrating our motor controller, the transmission controller, from a hardware diagnostics and functional safety standpoint. And then finally, we're also focused on system integration, looking at how the transmission and axle gear ratios can be optimized based on the motor's efficiency map, and also developing e-optimized brakes because their duty cycle becomes less demanding in an electric vehicle. The third design principle, the last I want to touch on, is focusing on maximizing reusability, which really means leveraging as many parts and pieces that we have available today in order to reduce development cost, improve overall reliability of the system, and minimize the need for new service parts. For example, we are focusing on using conventional axle housings wherever possible with the same suspension mount, so our powertrains can drop into an existing chassis and suspension with very little changes. We're using existing differentials, wheel end reduction gear, brakes, and electric actuators. We're also leveraging as much as possible our existing assembly processes and equipment of our base carrier and axle dressing operations. So through all of this, we're trying to drive down the cost, improve the reliability, and really enable our market to move toward clean transportation. That's our goal. Thank you.
Thank you very much, Mr. Bennett. Now, let's quote someone much bigger than us. To be a network or not to be, aka how important is a global and integrated knowledge of the powertrain to provide a tailor-made solution? Let's go to Germany. Andreas Grossel, what is the ZF point of view?
Yeah, before answering your question, thank you very much for the invitation to today's webinar and also to have the possibility to share ZF point of view. But now coming to the answer of your question. Yes, the knowledge of the complete driveline and also of the powertrain is essential to provide good solutions. ZF is known for more than 100 years now for transmissions. And the transmission always was linked very close to the engine and therefore to the powertrain. And so we have a lot of experience when it's coming down to the complete powertrain. But in addition to that, we are also delivering excellent chassis components for many years. So we also understand the complete vehicle architecture in commercial vehicles, trucks and buses. Of course, the vehicle architecture will change with the electrification, as we have seen also with the Volta colleague. But we understand these changes, we are aware about that, and we think we can handle that. Just to give you a few examples. Looking on a long-haul truck, space and packaging is really crucial. We need the space for the batteries or for the fuel cell and the hydrogen tanks. Therefore, it's really good to integrate as much as possible the complete driveline into the axle. And therefore, we also think that an integrated e-axle is the best solution on a long-term point of view. Besides, the powertrain electrification also creates freedom for new chassis concepts. This means alternative solutions to the current leather frame design, along with new suspension concepts like independent front suspensions, which, by the way, are already state-of-the-art in buses. And with the complete integration of an axle, for example, in a city bus, you completely can realize new interior designs. However, with the electrification of the powertrain, additional components has to be electrified, like e-compressors for the air supply, e-fans, e-PTO solutions, or e-steering. And ZF is working on all these kind of solutions. So in summary, yes, a deep knowledge of the vehicle and the complete powertrain is crucial to provide good solutions to the market. And based on our experience within ZF, we think we are well prepared for that. Thank you.
Okay, thanks, Mr. Grosso. Thanks to all of you. I guess this is the state of the art in the industry so far. Now it's time to engage quite an aggressive startup, as is typical of our journalistic approach. We might say EV is a solution provider which will play an even more pivotal role in the journey towards decarbonization. Massimo Galli, we know EV is active on both off-highway and on-road. So please tell us about similarities and differences between these applications. Please.
Thank you for your invitation. And let me introduce what EVE is. EVE is a company focused on electrification of special vehicle. What does it mean? Of course, we are focused on B2B vehicle and application, but in specific, we are focused on small series or very, very specific context application. For example, we work in mining, airport, on farm solution, rescue. And what does it mean for us, an e-axle solution? For a company like us, for our customer, to be able to have the integration of the powertrain, the electronic, the controller, all in one axle, allows us to build different solutions that are not just the switching from the internal combustion engine to the electric powertrain, but are exactly the kind of solution that allow us to build a different concept of vehicles. Because an e-axle allows us to work with special chassis that, for example, in rescue are very important. We can change the shape of the vehicle. We can allow the vehicle to do things that the internal combustion version of the vehicle cannot do. So there is for sure an attention on the environment. We want to be green. The company that we work for and we work with are green, but are companies that are looking for something that before was not possible to create. And for this reason, we are very happy to see a lot of companies, big companies that are traditionally involved in the electric, in the traditional axle for internal combustion engine solution like buses, truck, switching now or integrate also the electric axle. We are really waiting for a big portfolio of solutions that are made with e-axle because when I say we, I mean all the companies and the automotive company that works, for example, in mining solution, mining is really, or in farm solution, farm machinery now are for us one of the biggest markets for requesting electrification, and e-axle are everything if we want to just create something new that is not only replace the internal combustion engine and put another electric powertrain. This is in the end something that probably we are waiting for this solution since 2 years ago. When we start 5 years ago, there was not a lot of attention on this, but right now we saw that the market also is asking for this because companies understood what does it mean, the advantage of an e-axle. Of course, in buses, it's evident, also in truck for the city, it's very evident, but also in the niche of the market that really are not very niche because, for example, the farm is a huge market. They need this. So we are very, very happy to notice that right now the possibility to create something new is not something that we can do in the future, but it's something that we are working now with our customer in order to have a product ready in 12, 24 months, not years.
Thank you very much. It was a different point of view, of course, from a different company from the one compared to the one we have been talking so far. I have a question to Mr. Carter, if he's still there. I hope so. We know that Volta Trucks has different variants to the Volta Zero. So with smaller payload, we know it will have the 7.5 ton, the 12 ton coming in the next years. The question is the powertrain layout still the same compared to the current version of the truck? So with different wheelbase, different payloads, different gross vehicle weight, is it everything the same when talking about powertrain and of course e-axle?
Yeah, so when I think about our newer vehicle program for the 7.5 and the 12 ton, really from a powertrain perspective, the arguments that we've heard today and that I mentioned earlier, they just become stronger. You're in a vehicle where you've got less space available. You're in a vehicle where the customer is more sensitive to available payload, particularly when you transition from internal combustion engine to EV, and you're trying to give the range requirements of the typical duties of those 7.5 ton class vehicles. The argument becomes stronger, but for all the reasons we've talked about, the packaging, the weight, trying to be able to get the batteries in around the e-axle. And so for us, we are looking at a similar architecture for our newer vehicles.
Thank you very much for your answer to this kind of curiosity from our side. Now we've all got a better picture, I guess, and I hope so. I'd say let's move right on to the last waltz, aka the last round table, starting this time with Brist. Mr. Bonera, as for commercial vehicles, we see that also traditional manufacturers are starting to get more interested in developing vehicle layouts from scratch. Do you believe this is the way things will go in the coming years, and why?
Yeah, absolutely. That's the way. So years ago, this was done by startups. So they developed vehicle from the scratch, and they created a very interesting solution. And also thanks to them, we were able to create our new axle, new solution, test not only on bench, in our internal area, but in the field. This was for us really a big opportunity to create something new and verified. Unfortunately, many of them didn't go to serial production, but this was, let's say, somehow expected. But for us, it was really, really good in any case, because now that bigger companies are asking us to provide some specific solution for electric vehicle designed from the scratch, we are in the position that we have solution already proven and optimized. And not only axles, I told before, we are also combining axle with single speed or multi-speed, with a central drive, or now we are shortly presenting also our corner drive. That is a solution that is giving high torque to the wheel, leaving the central area free. And this central area free, we see also from recent inquiries that it's very appreciated, not only for delivery truck, where this free area can be used to load boxes, pallet, also from the rear with a low floor vehicle, but also for fuel cell trucks, where this free area can be used to pack tanks or fuel cell modules, or many components that are part of this truck or drones. So yes, that's the way we see, and that's what we are working on. So our solutions are specifically done for electric vehicle design from the scratch, because we see that this is the only way to get all the advantages of new electric vehicle layout coming from the new component that must be positioned on the vehicle. And only in this way the electrification of the vehicle can be an opportunity to improve the ergonomic, the space, and the vehicle itself. Otherwise, this is not possible. So for sure, the way is designed from scratch for us.
Okay, thank you. Another very interesting piece of this puzzle. So now, Mr. Grossi, let's talk about the other face of the coin in on-highway, I mean public transportation. ZF has a leading position, of course, in the bus field, which is certainly more mature than trucks in terms of electrification. How do you see the company among electrified commercial vehicles in the near future?
Well, first of all, we are glad that we are seen in a leading position when it comes down to the field of buses. However, we are quite sure that competition will increase as soon as electrification in the truck win its speed. Anyway, competition is good because it ensures the best solutions in terms of innovation, technology, quality, and cost. We as ZF see ourselves in a good position and well prepared for the future, and I will explain you why. You mentioned buses. Especially the city bus is a front runner in electrification. And we are in that market from the very first beginning, and now more than 20 years in the market. We have axle drives in the market, we have central drives in the market, and we have a lot of learnings in the new technology already behind of us. Besides that, about 70% of the sales share of ZF is linked to pass car business. And we all know that also in passenger car, electrification is coming very fast. We just have to think about the discussion in the European Union about banning the combustion engine latest in 2035. ZF has an own division with a lot of resources just dealing with e-mobility. And we also started e-mob development in passenger car already 20 years ago. E-motors, inverters, and control units are the key components of an electric driveline. And we are developing these components for passenger car in-house. And of course, we will leverage that synergies also for commercial vehicles. Sure, there are dedicated solutions and components for CV, but the basic technologies are the same. And we even can use the existing industrial footprint from the passenger colleagues. So we want to use our history and experience on CV business. We want to leverage our passenger car approach also for commercial vehicles. And then we are sure we will be one of the top tier 1 supplier for e-mobility system solutions.
So perfect. Now we move from the Constance Lake, across the ocean to US. Talking about Allison. Listen, 2 clues to the story Sunday. 10 to 10 vehicles of the Dakar race and the 3 years TCO test in Paris. Just to clarify, I give you another hint. Allison automatic transmission are really appreciated, but for some people they are maybe too expensive. For some other competitors, they are absolutely appropriate for the long range, maybe not for dirty environments. What's your reply about it?
Well, first of all, thank you for having me on your webinar. And to try to answer your question as best as possible, I think the starting point would be when you look towards whether it's an operator for truck or an operator for bus or an operator of a commercial vehicle or even a general vehicle in operation, is uptime. No one wants a broken down vehicle. No one wants the added cost. So when you look to, and as your case point there was the Dakar Rally, is one of the most difficult, arduous rallies, motocross sports there is in the world. And over the years has gone by, the Allison product has seen its way into the top 10 and even into the top 20, of which 17 of those finishers completed the course with the Allison 4000 series. So when you look to keeping a vehicle on road, if you can put a transmission, a fully automatic transmission such as Allison into a Dakar rally vehicle and carry that same technology over to a commercial vehicle, to a bus, for example, or a truck, then the operator has a bit more faith within keeping that vehicle on the road. And a lot of that is down to the longevity and the history, the quality and durability that my colleague Mike mentioned earlier, but as the transitional phasing we've got from transmissions to e-axle, and we embed that into how we build every transmission out there. So every transmission you buy from Allison or utilize in your own vehicles has that pedigree of ensuring vehicle uptime. Your point on the TCO study, which is an interesting case study we conducted over the 3 years with French fleet Dedishborg, did create a bit of an eye-opener. First of all, we got two considerations. One is the TCO cost, which can be easily overlooked, and one that always is the forefront of people's minds is fuel economy. So the purpose of this TCO study was to essentially address those 2 points. We find in this particular fleet that kept their vehicles for approximately 7 years. The TCO, when you compare an Allison fully automatic transmission, 3000 series in this particular case, against an AMT, an automated manual transmission, where again, going back to the point about vehicle uptime, driver retention, fuel economy was factored into this, delivery loads, whether you would need to replace a clutch or synchros, the full factor in oil and filter costs. The Allison fully automatic transmission was actually 2% better and stronger on a TCO study over those 7 years. So it's a long study. but the results proved for themselves. And I think when you combine these two elements of a Dakar rally, very arduous case, a TCO study of a major French fleet in Paris, you combine those two, you sort of understand where the heritage of a company such as Allison Transmission is coming from. And then to your general topic on e-axles, that then feeds itself into the design, the development of where we want to move into in terms of e-axle carryover, that pedigree, that heritage, and ensuring the quality and durability is offered into our next generation of products.
Thank you so much. And now the last part of our roundtable, Meritor. Please, Mr. Bennett, what about the interaction with AxleTech and Transpower and the opportunities for electrified axles in quarries and building sites? It's a different area.
Yeah, so regarding AxleTech and Transpower, those were two strategic acquisitions for Meritor, primarily to accomplish two different objectives, but somewhat related. We acquired AxleTech's off-highway business, specifically to expand in the off-highway segments, primarily with conventional axles, brakes, and suspensions, but to a lesser degree with electric systems as well. Transpower, that acquisition provided us with full electric vehicle system design and manufacturing capabilities, including vehicle controls, power electronics, electrified accessories, and battery packs. So we could go to our customers and provide a full EV system if that's what they desire. We've now fully integrated both companies and we're going to market with those products. And I would say that both acquisitions do open up more opportunities to electrify axles in certain off-highway segments, which is what you were asking. And one segment that's already moving towards electrification is terminal tractors. So terminal tractors are captive at ports and warehouses, so they can take advantage of local charging. Their use case is very well suited for electrification, a lot of start and stop application. We're seeing that transition already taking place. Another off-highway segment we see opportunity for electrification and e-axles is lift trucks, specifically heavy lift trucks. They are also captive at ports and warehouses, and they also have a favorable use case for energy recovery because they lift and lower heavy containers all day long. And the equivalent to that is accelerating and decelerating a heavy truck. So you're consuming energy when you lift, but you can recover energy when you lower. So it's actually a very favorable use case. And one other segment that we see a lot of opportunity and we're targeting as well is mining. So mining trucks, they operate in enclosed environments all day long. They are especially sensitive to clean emissions. And also the duty cycle, they typically run uphill and downhill all day long with a lot of cargo. So another use case that we see very favorable, and we're looking for the electrification. So to answer, yes, there's absolutely opportunity in the off-highway space. It's lagging a little bit on the compared to the truck side, but it's eventually going to come there too.
Thank you. Also, the second roundtable is coming to an end, or came to an end. Before going to the end, towards the end of this webinar, I would like to summarize what we said today, and I would like to ask our speakers to help us. So the question we imagine for the title of our webinar was, is e-axle the leading solution to maximize powertrain efficiency? Talking about, of course, commercial vehicles. So I would like to make this question to all of our panelists and also add something different. So which are the main tricks, the main obstacles when it comes to the adoption of this technology? So when it comes to the success of this technology into the market? I would rather start from Stuart Bradley, from Ricardo. So what's your idea about what's your answer to our question?
So we think that EDUs are the most likely commercially acceptable solution. The reason for this is the improved packaging. We believe that the cost trajectory is lower than other solutions, and we believe that the likely impact of efficiency, cost, and packaging as a design parameter and criteria set is the most with a combined EDU. So this is combining the motor, inverter, and transmission.
Okay, thank you. So we'd like to continue in order of appearance. So please, Mr. Robert Carter.
Thank you. I mean, it's been fantastic to listen to all the speakers today, and I think it's really encouraging, particularly when I think about Volta's development process alongside the e-axle over the last 2 years, and seeing now all the comments we've heard today, different segments, areas, opportunities for e-axles going forward. And I think that speaks to and demonstrates the suitability of e-axle as a particular niche EDU, if you like, for commercial vehicle applications. That the challenges are going to remain in some of the areas that we've spoken about, whether that is the contribution the e-axle makes to the total cost of ownership of a vehicle. That's both BOM cost and that's both reliability over the life of the vehicle. It still has a role to play in efficiency. It has many levers that it can pull with the integration of components, the integration of the inverter, if that's the kind of mechanism that people choose. There are many opportunities to chase down these targets, but there is still a long way to go. And as an OEM, we're certainly going to be pushing for improvements in those areas. But yes, it's good to see all the topics that have been talked about today.
Okay, thank you. And now, Allison, please, Mr. Foster or Brooks. Mr. Brooks.
I think we definitely believe that, the e-axle provides a lot of efficiency, not only from, operation, TCO, but also just that packaging. I think, there's a lot of value in being able to drop these solutions in where the current powertrains are today, in terms of suspension points, mounting locations. We recognize this is going to be a long, slow ramp, for full adoption of electrification, and the OEMs are going to be in a position where they're going to need to maintain those conventional platforms, and being able to have the least impact to those vehicles and platforms is going to be critical. So there's an operational efficiency that comes along with the e-axle as well. I do believe that, in the off-highway space, I think there is value in the central drive solution, but, in the on-highway, I think we're starting to see more of a settling, if you will, in the market towards that e-axle location, for all the reasons that were talked about earlier in terms of, the packaging and moving everything into a central location. There's a lot of challenges. I think there's a lot of tremendous organizations on this panel that can come through those challenges over time. Allison certainly hopes to be at the forefront of that.
Mr. Brooks, of course, if you want to add something, feel free to do that.
I appreciate that. Thank you. I think Mike summed it up very well. It's a very aggressive, ever-changing market. Everyone's trying to keep pace with this new technology. E-axle, it certainly has its place, and I think one of the major benefits is direct efficiency to the wheels. And as Mike said, packaging. When you look at all the different segments, as Robert was mentioning just then, there's so many opportunities, so many different segments it could slot into, and you'd reap the rewards. So, thank you.
Thank you so much. Danilo Bonera, Brist. We've heard about your opinion before during your speeches. But what about the challenges? Can you say something more about the challenges, the obstacles, what we were saying before?
Surely the challenges, I think, are also, let's say, bigger than only the vehicle design. That are maybe some mental constraint from people that are used to design a traditional combustion engine vehicle, but this is something that was more present in the past years. Now we see it's going well also from this side. So our vision, yeah, sure, electric axle integrated is giving more efficiency, space saving, weight saving, even if as Brist we don't push too much for integration, because we prefer to keep the motor as a let's say, partially flexible component in order to select the best for the different mission or for a localization purpose and so on. But fully agree that EDU is a must to create very valuable vehicles, electric vehicles.
Okay, Mr. Glosson, what about the multi application? So expertise, knowledge of ZF. What can you say?
Yeah, coming back to your question, I think I expressed it. So we think that the e-axle is a good solution for the future, and the main advantage from our point of view is packaging. Packaging, number one, then we have efficiency, but also the new freedom we will get on the vehicle layout. You were talking about obstacles. I would say challenging is the better word, or challenges. In the end, we are bringing two products or three products, an engine and transmission and a conventional axle, into one new product. So the high integration is a challenge. And I think it was also mentioned during the discussion, we are now bringing everything to the unsprung masses. So thinking on control units, inverters, if you have integrated it, it's a challenge we have to manage. And talking about the different applications you mentioned, in the end, we need smart modular concepts, beginning from light commercial vehicles to medium duty, but also to heavy duty, to keep the total costs and TCO costs under control.
Okay, thank you so much. So we are approaching the end. The last two speakers are Mr. Bennett, who merited as well is becoming a very complete specialist. And so what you have to say after you, Mr. Galli, please, Mr. Bennett.
Yeah, so just on your question about the e-axle, so I absolutely believe that the e-axle is the right solution. It's the best solution for all the reasons that have already been mentioned: the packaging, the ability to kind of reconfigure the vehicle and take advantage of that, the weight savings, and I also believe the cost trajectory will be lower for a well-integrated and well-optimized e-axle compared to the alternative solutions. The challenge is that I think one of them is, number one, it's availability and it's technical maturity, right? So all of these are being developed or are just now coming to the market, right? So, and as well as the industry is developing these products, they are new, and there's going to be continued reliability growth as we go. So that's just one thing to keep in mind, and we'll get there eventually, but just being new technology, it's just something to acknowledge and to plan against. So really, I think, if you fast forward a year from now, we'll probably say, yes, the industry is moving towards e-axle, and the discussion or the debate is going to be around the architectures of the various e-axles, because there's a lot of different ways you can do it, right? And there's pros and cons. So I think we'll be debating that next.
Okay, you'll be very clear. Thank you, Mr. Galli. The conclusion is yours.
So, a short answer. For us, axle is just a great opportunity. We don't see any problem. We are waiting for e-axle because we work with innovation. We work in a specific sector where we have to make the difference. E-axle allows us to do that.
Thank you very much to all of you from my side. Now we can say we have a better understanding of what it means to electrify a commercial vehicle, as well as which are the additional opportunities granted by electrified powertrains. Thank you, Fabio.
Okay, on behalf of Powertrain, you can see on my shoulder, and Sustainable Truck and Van, I sincerely thank all of you who followed us, and especially the panelists. So summarizing, Mr. Stuart Bradley from Ricardo, Robert Carter, Volta Trucks, Michael Foster and Ashley Brooks, Allison Transmission, Danilo Bonera, Brist, Andreas Grossman, ZDF, John Bennett for Meritor, and Massimo Galli for EV. So have a good time. So We will see you for the second step, Sustainable Powertrain to 2022. Enjoy your summer holiday. As you know, August is a death month of the year in Italy. So we will see you again in November. We will talk about the connection between biomethane and hydrogen, Repower Europe, and etc., etc., etc. Thanks a lot.
Thank you.